In the last video you have seen that when laser light fall on any surfaces it basically make some pattern. If we use only a slit, a gap between the two surfaces, then the diffraction take place, and when there is no space, light reflects. When the light reflects from the surfaces of a CD, a pattern develop. Basically that is the result of diffraction. When we use a scale and the light fall on it, then also a pattern develop. Now I am using two slits. I will use only one at once with the laser. So these are basically two blades. I made some space here. I cut down this paper right like this, and then after I have attached these two pieces of blade here and these two pieces of blade, and the gap is maintained different. Here the gap is very small between the two blades, and in this particular slit I have keep some larger distance between the two slits. You can see it, and into this. So I will use this simple laser light which is available in market, and I will fill light on the surface on the slit, and on the screen we will see the effects, what happens. So now I am closing the switch of the tube light. So light is falling on the slit, and as a result what is happening, this is my blade, and as a result what is happening on the screen just behind of the paper, you can see that when laser light fall on it, a pattern is developing, a very interesting pattern. That pattern basically is the result of diffraction, and here because thickness is more, so that is not so good. So I am going very close to the screen, and then I will try to show that the pattern of the from the single slit using this monochromatic source, that is a laser light. Here you can see number of, there is a central maxima, and then after there are other minimas on the screen. A horizontal line, it's the result of diffraction. We can vary the distance between this slit and the laser source, and as a result we observe the pattern, the distances between the central maxima and the first order maxima. So you can see here clearly, this is the result of diffraction. A very good demonstration of the diffraction we can see using the two blade pieces and this simple laser light. So here you are observing only the central maximum, but I will try to show you. First of all, let me know where is this. This is the point. So zoom is so high. This you can see. A central maxima and very small first order, second order, then up to nth order. You can see the pattern. This is a horizontal line. Light is diffracting. So center part is the maxima part and the other. Otherwise you will see the light. This is original light without any single slit, and if this is the single without any light, without any slits. This is the result of the laser light. But when I will use the single slit, then see the result. This is my paper. I am using this paper. This is blade. Light fall on it. And as a result, you can see on the screen that now intensity has been distributed. Now there is a central maxima on the screen and other maxima also horizontally. So a very good experiment to show the diffraction of the laser light. This is possible only with the laser light. This is not possible from the white source. If I will use it a broad source, this source, then there is no chance of the diffraction. But as a result, you will see that a wonderful pattern develop on the screen if it is visible. So I will try to show it. On the screen. If I rotate the bulb, the slits, light which passes through the slits also rotate, because I am using number of LED, so image from each LED is rotating from the same direction. So diffraction is not possible from the laser, from the white source. So nothing is visible right now.